is the point-slope formula. So point-slope formula is what you have to look for. Y minus y1 is equal to slope into x minus x1. So I'm going to call this point x1, y1. That's no other point there, so it can as well be x1, y1. And then I'll plug it into the equation. So I have y minus 5 is equal to the slope is negative 2 given to me here into x minus 0. X minus 0. X minus 0 is x. And so now when I open the parentheses, I have y minus 5 on the left-hand side is equal to negative 2x on the right-hand side. Add 5 on both sides. And we have y is equal to negative 2x plus 5. So this is the equation in slope-intercept form that they want me to find. Okay, but so that is number 3. Is there any question with number 3? So we found the equation with a slope of negative 2 and y-intercept of 5. Any question? If you do have a question, let me know. Or you can
I
put it
do
in
have
the...
a question.
Yes, ma'am. Yes, ma'am.
Um, so I know you said we have to use that formula, but could we also use like the y-intercept formula and then plug in slope and the point and do it that
Yes,
way to get the
if you
equation?
can. If you can do it that way. But I'm telling you that this is the best way to do it. But if you can use y-intercept formula, that's good. So let me, if everybody is looking, let's see what she's saying. She's saying, can we say y equal to slope into? So she's asking about this. Yes, you can. That's good. Because you can plot the point in 0, 5 and the slope, and then you find b. So you can do that. So 5 is the value of y. So let's just put y here. And the slope is negative 2. So we do negative 2. And x is 0. So we put 0. And then we are going to be solving for b because we don't know b. Okay, so 2 times 0 is 0. And therefore, we find out that since this is 0, b is equal to 5. So yes, you can use this method. Yes, you can use this method. So I'm not trying to say, well, even if I said that, I'm sorry, I had to withdraw that. You can use any other method that you already know how to use. But if everything fails, it's always good to use the points slope formula. Well, that's good. That's a good question, Amaziah. That's good. So
Okay,
you can
thank
use
you.
points law. Yes, you can. Thank you so much. But you can use the points law formula. You can also use the y-intercept formula. Any other question? Yeah, that's good. So I hope people learn from your question. So let's go to question. Let's go to number 4. We're not actually trying to do all of them one by one. I mean, we're just trying to, I'm not trying to, there are going to be about 15 questions in the test. I made them, I think 25 or 26. So there are 26 questions in this practice test. I'm just going to select 15, not more than 17. So, and then I want you also to know that I'll select them from this practice test. But they are not going to be, you see, when I select, I reshuffle them so that the numbers will not be exactly the same. But if you know how to find the slope-intercept formula, you know how to find it. If you know how to find the equation of a line, you do know how to find it. So whatever method, I'm going to get to 2 points. When we're given 2 points and we are told to find the equation of a line in slope-intercept form, we better know how to do this. We have done this a lot, but that is so. By the way, I'll take the roll. What can you start doing number 6 while I take the roll? Because I have to take the roll and know who is in class. They want me to take, let me show in the grid form. I want to make sure that I check everybody in class. All right. So I want you to attempt number 6. Attempt number 6, and I'm going to do the roll, and then I'll continue. Okay. Jordan A. Please unmute yourself and answer. Jordan A.
Here.
Okay. Lauren C.
Here.
Okay. Jaden C.
Here.
Connor C. Is Connor here? Connor C. Absent. Amaziah is here. Kendall J. Is Kendall J here?
I'm here.
Okay, good. Cornelia L. Cornelia Ledford. Cornelia? Not here. Riley Laos.
Cornelia's here.
Here.
Sorry.
Oh, is Cornelia here?
Yes, ma'am.
Okay, all right. McKinney, Liza Matthew present. McKenna M.
Here.
Molly M.
Here.
Lucas M. Lucas Morrison. Anna O.
Here.
Lucas P. Lucas
Here.
Peters. Okay. Trinity P is here. Caroline P.
Here.
Amelia R.
Here.
Seth R. Seth R. Seth Roach. Seth Roach is not here. Emma S. Emma S. Emma S is not here. Calvin W. Calvin
Here.
W.
Here.
Okay, all right. So let me mark talk call those who didn't show up. Lucas Morrison is not here. If you're here, answer though. Seth Roach is not here.
I'm
Emma.
here.
Oh, okay. All right.
Sorry.
That's okay. All right. Sally. Emma Sally is not here. Lucas Morrison is not here. Connor Kraft is not here. So 3 people are not here. And I called them twice. So because I'm still supposed to mark attendance. We don't really have a good weather, but you can still log in from your hostel. Okay. And so is there any question? This time we have 2 points.
Connor's here.
Oh, is Connor here?
Yeah.
I'm here.
All right.
For this.
Good.
I did.
Okay, Connor, that's good. Okay, now Lucas Morris is he here? Is Lucas Morrison here? Is Emma S here? So missing just 2 people. All right. So let's go to question 6. This time we are given 2 points, and we are told to find the equation of a line in point-slope formula. So in this particular case, you must find the slope. So you start by finding the slope of the line. Remember the formula increase in y over increase in x. So the increase in x, you have x2 minus x1 increasing y x, y2 minus y1. Okay, and then now I call the first point x1, y1, and I call the second point x2, y2. So let's find the slope. So y2 is 3, y1 is -9. So 3 minus -9 divided by x2 is 8, x1 is -3. So 8 minus that -3. So I have minus minus in the numerator and minus minus in the denominator. So I'm going to be adding 3 plus 9 is 12. So the slope is going to be 12 in the numerator divided by 11 in the denominator. So I have the slope. The slope is 12 over 11. So now I am going to write the equation in slope-intercept form. So when you start writing the slope-intercept form, you can choose any of the points. That's like how I like to do it though. Choose any of the points and I can choose point number 2. Okay, so now I have y is equal to, what's the slope? 12 over 11. Okay, and then the point I have is, and by the way, I can still use the point slope formula like I used the other time. So I can, so this is y here, this is x, and my x is 8. And just like she asked, she said, can I use? Yes, you can. So now I will, let me put this 3 here so that, and then 12 times 8 divided by 11. So I have, if I multiply across, or I just have it like that, 3 is equal to 12 times 8. 12 times 8 to multiply, 8 times 2 is 16. 8 times 1 is 8, that's 96. 96 over 11 plus b, because I'm now going to solve for b. All right, so, and then b will be 3 minus 96 over 11. And this is 3 over 1, I hope you know. So what I can do is now say 33 minus 96 over 11. So 33 minus 6 over 11. 33 minus 96. So when I have 33 minus 96, I have 63 negative. So then I have the slope. So it's negative 63 over 11. Y-intercept, I mean. So y-intercept is negative 63 over 11, equal to negative 63 over 11. Okay, now I can plug in the y-intercept and the slope. Alternatively, you can do it with a point slope formula. Either way, you will get the same answer. If you find any problem with, if you maybe you don't like the way I did it, you can use point slope formula again. And I hope it's not going to be confusing. I think I might have to continue with my point slope formula. So now I have the equation in slope intercept form is y equal to slope given to us. We already have 12 over 11. All right, and we have the y-intercept as negative 63 over 11. If we try to do it using the point slope formula, we get the same answer. Hopefully. Did anybody use point slope formula? Did we have the same answer? Did anybody use? Well, I think if you, I'm not even saying, I think if you use point slope formula, you get the same thing. So we will not be wasting time on one number. But you just know we have 20, 6 questions, and we will have about 15 to 17. I'm going to make the test later. Okay. So test will be next class. So we already know how to, so whether we are given points, slope formula, or 2 points, we know how to write the equation of a line. Any way you want to write it, the point slope formula or the slope intercept form, that is okay. Okay, consider the following. Um, Number 7. Consider that following equation. It says express the given equation in slope intercept form. Plot the point on the line with the x coordinate of -9. So I know you can do it. Everybody can now isolate the equation. So if you isolate this equation, you have plus 4x on both sides. So now you have 4y. 4y on this side is equal to 4x plus 24. If you divide both sides by 4, you get y is equal to x plus 6. So you have this equation, and then you said plot the point on the line. So I know you can plot this point, plot the point on the line with the x coordinate of x equal to -9. So which means you can just find the point on the line where x coordinate is -9. You can actually find that point. So you're given x -9. You can find it from here. You can find that point from here. If x coordinate is -9, we can find the y coordinate. So y is equal to -9 plus 6. So the y coordinate is going to be -3. So the point is going to be -9, -3. And so you plot that point. In other words, they give you one point, which is x equal to -9, and you can find the other point. 2 points make a line, by the way. And you can use the slope intercept one. By the way, let's sketch it. So we can sketch that. Doesn't look pretty good, but that's okay. So the y-intercept of that line is 6. So I'm plotting 6 here. The slope is -9/1. So -9 means I'll go down. I will go down 9 and go over 1. So this is 6 and 3 is somewhere here. So I'll go down here and go over 1. Let's say that 1 is here. Go ahead, 1 is here. And if I connect these 2 points, because 2 points make a line in a coordinate plane, so I have the equation whose so the equation is, by the way, I want to make sure, let's make sure the one I just drew. So I'm going to clean this one and make sure that we drew the original equation. I'm going to draw the original equation. The original equation, which we are told to find, is y equal to x plus 6. So I want to plot the point 6, and slope is 1. So I'm going to go up 1 over 1. Up 1 here over 1. So I'll go up 1 over 1 from 6. The slope is, so I connect these 2 points and extend them. Connect the 2 points and extend them. So the line has a positive slope. So that is the line we are told to graph. That's the line we are told to graph. And if that they also wanted us to plot the point where x is -9, and we actually found that point to be -9, -3. So let's find the point. So -9, -3, somewhere down here. -9, -3 will be somewhere down here. It could be on the line, but it's a point in the third quadrant. It's a point in the third quadrant because x is negative, y is negative. Because x is negative, y is negative, the point is is inside the third quadrant. And if this is not a sketch, it can actually be on the line, actual line. Okay, I don't the calculator in this is not functioning well. So I didn't use it in the other class because it's not, this laptop is not, doesn't have a calculator. But let me see. Let me see. There's no need downloading a calculator right now. But anyway, you kind of know what I'm saying actually. Okay. So and then you can plot the point as given. And then there's another point they told you to plot. Okay. It says consider the following equation. Step 1, express the given equation in standard form. I'm talking about number 9. Everybody look at number 9. Consider the following equation, x plus 1 equal to 0. Notice that there is no y variable there. So it's actually a linear equation in one variable. Whenever you have a linear equation in one variable, you have to be careful because that line could be a vertical line or a horizontal line. So first of all, let's rewrite this equation in standard form as they asked us to do. Let's rewrite it in standard form. The standard form of equation is ax, of a linear equation, is ax plus by equal to c, equal to c. So ax, for this time, I have 1x, so I'm just going to put 1x there. I just put x. All right. All right. Then there is no y, so I'm just going to have 0y. And c is going to be -1. So I have written the equation in standard form. Make sure you know how to write the equation in standard form. It will help you observe a lot. So I have x plus 0y is equal to -1. I hope you know why it's -1. I move the constant to the right-hand side. Okay, so what else do I need? What else do I need? Let's see what the question says. Simplify your answer. We did. We wrote it in standard form. We simplify the answer. Then it says plot the point on the line with the given y coordinate, y equal to 0. Okay. So in this equation, there is no coefficient of y. So actually, let's graph the equation x equal to -1. So let's say that -1 is here. So this is x equal to -1. So let's make it here. X equal to -1. Oh, well, I'm putting it somewhere here on the left-hand side for negative. So I'm just going to continue this line. Continue this line. It's a crooked line. Well, anyway, I'll continue this line and I have a vertical line. Whenever the equation says x equal to c, it doesn't matter what it is. X equal to c is a vertical line. And whenever you have a vertical line, let's try and find the slope of this line. Let's try and find the slope of this line. Remember, if I rewrite this equation, it's a vertical line anyway. So the slope of any vertical line is undefined. The slope of any vertical line is undefined. Okay, but how do we know it's undefined? Well, let's rewrite the equation if we want to. Uh, um, if we rewrite that equation, we notice that we know only the value of x, value of y is not there. Slope is y minus y2 minus y1. Let's write it so that over x2 minus x1. Well, we don't have y2. We don't have any y2. So we can say that the denominator is going to be 0 when we do that. So it is undefined. The equation will be undefined. Okay. All right. So okay. So let's when the slope is undefined, we already talked about that. The equation does not contain a y because the equation is undefined. Consider the following equation. Look at number 10. Let me see if we can. Let's do it. Look at we have done this kind. Let's see if we do another one. Okay, these steps. Grab the solution set of the following. So let's get inequality. Let's do some inequality. Grab the solution set of the following. You can do it without calculator, you can do it with calculator, but it's important that you know how to do it without calculator also. So this is an inequality, and we have to be careful now because we know any division by a negative sign changes the inequality. Okay, so we have 3y is less than, I'm moving 2x to the right-hand side, it becomes negative 2x plus 6. I'm writing it in slope-intercept form though. That way you can, so this is divided by 3, divided by 3, divided by 3. So then y is less than negative 2 over 3x plus 2. Y is less than negative 2 over 3x plus 2. So what we're going to do is sketch the line. We're going to sketch the line here. So let's sketch the line. I'm talking about sketching the line when it is equal sign here. I want us to know that when we sketch the line will not be included. The line will be a broken line. Remember, it's going to be a broken line because it's only less than. So I'm going to sketch the line. The y-intercept is 2, so let's make it 2 right here. I plot the y-intercept, plotting the y-intercept right here. And then the slope is 2. I'll go down 2 and over 3, go down 2, and I am at the origin and go over 3, go over 3. 3 is somewhere here. And then I join the points, the 2 points, because 2 points make a line. And I'll connect it. When I finish connecting them, you tell me something I'm not doing right. I'm connecting somebody has to answer this question so I know if we are all following. So this is the line. Of course, we know it's a line with a negative slope, negative 2 over 3. It's a line with a negative slope, negative 2 over 3. Okay. Now, what is wrong with the line? Somebody tell me something is wrong with the line. Somebody unmute yourself and say why. Why do you think we need to do something on that line? And we will actually
It
pick a...
needs
Go ahead.
it needs to be dotted.
Exactly. Thank you so much. You need to be a dotted line because it needs to be a dotted line. So I'm going to make sure that we use dotted line. So let's make it dotted line, broken line. y broken line, the inequality sign is less than. Whenever it is less than or greater than. First of all, so the line should be broken. And another thing is that we need to choose a solution region. So which region is a solution region? A line divides a plane into two half planes. The half plane on the right, half plane on the or above and below, whatever you say. Okay, so which half plane is the solution region? It cannot be both of them. So now we're going to pick a point and we're not going to guess it. So we're going to pick a point. And I picked the point 0, 0. I want to test this point in the line and see if it satisfies the inequality. So I have 0 is less than, whatever is here multiplied by 0 is 0, is 0 less than 2, is 0 less than 2? Answer yes or no. Why?
Yes.
Yeah, 0 is less than 2. Good. Therefore, the point 0, 0 is in the solution region. The point 0, 0 is in the solution region because 0 is less than 2. So the point 0, 0 satisfies the inequality. And it cannot be, any point we pick cannot be on the line, on the broken line. So we have to shade the solution region. We are told to shade, I don't think we are told to shade. Yes, graph. So whenever we are told to graph, then we can shade the solution region. So the solution region is the half plane below the dotted line. The solution region is the half plane below the dotted line. Y is less than negative 2 over 3x plus 2. Any question? Any question? All right, so we did that. We did that a lot the other day. And we have to actually make sure we do the one when there is an absolute value. There could be an absolute value there. Okay, another inequality. This time it is a closed line because we have less than or equal to. So the first thing we want to do is to solve the inequality to look like the slope-intercept form. Okay, so I want to subtract 10 from both sides. And then I have negative 5x is less than or equal to 2x minus 10. All right, the next thing I want to do is divide all through by the coefficient of the inequality. Be careful this time. Everybody be careful. We are dividing by a negative sign and there's an inequality. So divide by negative 5. I'm dividing by a negative. This inequality will flip to greater than or equal to. I hope this is clear. So we're dividing all through by negative 5. Divide all through by negative 5. So the inequality will flip to greater than or equal to because I divided by a negative sign. The same thing if I multiply by a negative sign. So the division by a negative sign flips the inequality. Multiplication by a negative sign flips the inequality. So now I'm going to go to the right. So I have this is y. So y, sorry. So now I have y is greater than or equal to negative 2x over 5 minus here. So I have plus 2. All right, so I have y is greater than or equal to negative 2x over 5 plus 2. Okay, so let's sketch the graph. So we have a graph right here, and we are told to sketch it. and find the solution region. Whenever you're told to sketch the inequality, they don't have to ask you for solution region. They don't have to ask you because that's why you're told to sketch it. Telling you to sketch it means you should actually know the solution region. You should know the solution region. Okay. So we are going to graph this point. So the y-intercept is 2. The slope is negative 2 over 5. So I'm going to fall 2, go down 2, and go over 5. Down 2 and over 5 somewhere here. This is a sketch. All right. I am going to connect these 2 points with a solid line, and then I will continue to the right, and then continue to the left. Tell me if the solid line is good, or do I need to change anything? Do I need to change anything? The solid line, is it good or not? The inequality sign says greater than or equal to. Somebody, another person, because we already know this. This is a review class. We already know this, hopefully. We're supposed to have known this. So another person, tell us. In fact, whoever it is, anyway, tell us. I use a solid line. Do I need to change something? Anybody? Anybody? I hope you are studying for the test. I hope you're studying for that test. All right.
I think the solid line's okay because it's greater than or equal to.
Great. Great. That's good. Solid line is good because it is greater than or equal to. So any point on the line is included. That's what it means. Any point on the line can be included. So now the next thing is to find a half plane, which, because a line divides a plane into 2 half planes. Now we want to know which half plane. Is it on the one on top or the one below? I will again choose the point 0, 0. I will choose the point 0, 0. If I plug 0 for y and plug 0 for x, I will have 0 is greater than or equal to 2. So we can see 0 is greater than or equal to 2. Is that true? Can 0 be greater than or equal to 2? This is my question. That is not. 0 is not greater than 2. Therefore, it does not. The solution region is not this one. Therefore, the solution region is the region above. Because if the point does not satisfy the solution region from one half plane, then it must satisfy it from the other half plane. There are only 2 half planes. So if the point from the half plane I pick did not work, then I will pick up another point from the half plane, but I don't even have to pick it up. I just shade it. I shade the solution region. The solution region is the half plane, and the solid line is included. Every point on the solid line is included. I hope this is clear. Yes. Okay. All right. All right. Suppose we have graph the solution set of the, okay, we have already seen less than. So let's go and see another one. Solve the system of 2 linear inequalities graphically. So this, you can solve this with your calculator like we did the other day, but it will be good to also to solve it by hand. You can also learn how to solve it by hand. So what we can do now is we sketch the equation are already in slope-intercept form, both of them. But we have to be careful. The inequality right here is closed. So points on the line are included, but the inequality here is open. Points on the line are not included. So we can sketch. I'm going to make a small sketch here. That way I don't, okay, I'm running away. Just going to make a small sketch here. And I'm just making sure that I'm going to grab the first equation when the slope is 1 and y-intercept is 1. So this is y-intercept is 1 right here. Y-intercept 1. And the slope is 1, 2. That's 1 over 1. So I'm going to go down 1 and over 1. Down 1 and over to the left 1, because the slope is positive. So I'll connect the 2 points with a solid line. Why? Because it's a closed, the inequality is closed. Then I will check the solution region for this line now. I will check the solution region. So let me pick a point. Pick a point 0, 0. If I plug in 0, 0 here, 0 is less than 1, does not make sense. 0 is less than or equal to 1 does not make sense, because 0 is not less than or equal to 1. I hope everybody look. I picked a point 0, 0 and I plugged it in here. 0 is less than 1. Well, yeah, 0 is less than or equal to 1 is correct. So 0 is less than or equal to 1 is correct. So the solution region for this one is, I'm going to shade this one with red. Then I'll shade the other one with another color. So 0 is less than 1 is correct. Solution region is the half plane down. So now we want to graph the other half plane. Okay, so this half plane, the y-intercept is 5. So let's make it 5 right here. And then the slope is 5 over 1. So I'll go down 5 and over 1, make it here. May not even be there, but anyway. All right. And then I can connect the 2 points. 2 points make a line. And continue the line to infinity, because they're going to infinity. The important question is that the inequality is only greater than, so the points on the line are not included. In other words, I am going to supposed to use broken lines to draw that. That's one. Another thing is that I have to pick a point. And when I pick a point, it has to satisfy the inequality. So first of all, I want to use broken line for that inequality. So broken line, broken line, broken line, because the inequality has greater than only. And then I pick a point, and I would like to pick the point at 0, 0. So I like to pick the point at 0, 0. Okay. If I pick the point at 0, 0, and I'll test it here. So let me see, 0 is greater than 5. That is false. 0 is not greater than 5. 0 is not greater than 5, so it doesn't satisfy. 0, 0 does not satisfy this inequality. In other words, the region to be shaded should be the region here. So I should be shading the region this way, because I picked up a point on the other side. It did not satisfy the. Okay, the question now is, what is the solution region? Another way of saying which region is intercepted by both lines. I want everybody to look. The region we can see is this small intercept, the narrow intercept here. This is the solution region. That is the solution region. Remember, you have to shade it. So you shade the solution region. If you don't have a ruler or what, but your test contains graphs. Your test will contain graphs. So if you bring a pencil and a ruler, that will be good. Listen, if you're taking a test somewhere else, if you're somewhere else, you can tell them that you are allowed to use a ruler and pen, or if you use a mathematical set square, whatever you have to draw a straight line. On the test day, you will be allowed to use a cue card to write whatever you think you forget, just a cue card. And then I don't know what you call it, like we call it cue card. So just a card that you write the things that you don't want to forget. Maybe the slope-intercept form, the equation of a line, point slope formula, maybe whatever you think you don't want to forget, you write that, and then you can bring it to the test, and I will see it too. When you finish, you put it in your test. So I'll look at it too. All right, so we now agree that we have to be careful to make sure we shade the correct solution region. So the correct solution region is just this small place. But guess what? It continues to infinity. So the more you draw it, the more it gets to negative infinity. Continues to negative infinity. You can see it's going to negative infinity. Any question? Any question? All right. All right, so I'm going to make sure see if we have any. In fact, before we go to any other, let's just draw. Suppose we have an absolute value of, let's just say, y plus 2 is greater than 2x. You can have something like this. You can have something like this. So if you do have a question like this, well, I know you will, but sometime you're going to have it. So if it is greater than or less than, if it is greater than, then you write two equations, two inequalities. The first inequality is y plus 2 is greater than 2x. And the second inequality will be y plus 2x again, y plus 2. You flip the inequality and then change the sign of the quantity in the right. You flip the inequality. So you will be graphing two linear inequalities. So whenever you have absolute value inequality, you first of all recognize that for the absolute value, you will have two inequalities. So you rewrite the inequalities and then you graph the inequality. Graph each of them and find the solution region. So if I solve the number one, I will have number one implies y is greater than 2x minus 2. Number two is y is less than negative 2x minus plus 2. Well, because it's going to minus. I'm bringing to the right. So this is very important. You can be given absolute value inequality, We did have to do it when we have absolute value equation. Okay, then you graph the one with greater than inequality, you graph the one with less than, and shade the solution region on each of them. There may not be a solution region. Can just say that. There may not be, because when it is greater than, you have to. So everybody already knows how to sketch the graph. But the one thing that is added is when the absolute value is there, first you have to solve the absolute value. You're solving the absolute value by creating two linear equations, and then you find then you solve the equation. So create two absolute value equations. The absolute value gives you two linear equations. The inequality makes it inequality, so that you're going to be solving two linear inequalities. Then you graph them. Okay. All right. Let's see. Let's see. Solve the system of two linear inequalities. So this one looks like the one we just talked about. Solve the system. So it looks like we have talked about them. Number 16, we have already talked about that. And remember that if these two lines intersect, each other, they have one point of intersection. I want you to note that this one has a dotted line, so all the points here are not included. Points on the line on this one are not included. And this line has a solid line. This one, all the points are included. So should be able to graph the inequality. Solve the system of two linear inequalities graphically. Okay, so if you're told to solve it graphically, and then I just have to, let's make a sketch. So we have y is greater than or equal to negative 5. So we're just going to graph it as if it is y is equal to negative 5. So this is negative 5 here. But now we have greater than or equal to. So it's not going to be dotted line. It has to be a solid line. So this is y is greater than or equal to negative 5. Okay, and then how do we shade this one? If I pick up a point here now, I already know that 0 will not be greater than negative 5. That will be false. So let me see. Let's pick up a point here. Okay, so if I pick up a point here, yes, 0 is greater than, okay? I pick up, so I will shade the region to the right, because the region to the right satisfies the inequality. The region to the right satisfies the inequality y is greater than or equal to negative 5. Okay, now I am told to graph the line x is greater than negative 1. Remember, when x is equal to negative 1, I have a line to the left. This is x equal to negative 1. And if it is less than, then, by the way, it is greater than here. So x is greater than negative 1. Okay, so they're all greater than, but the line will be a broken line. So everybody should be careful. The line x greater than negative 1 will be a broken line. All right.